Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
My mathematical quest for the solution of the toughest problem in calculus was like searching for a black goat at night. Briefly, this is my supercomputing story. I experimentally discovered how to open the door that takes the modern calculus across a new global network of tightly coupled processors that were already available in the market that shared nothing, or across a new internet that is a new supercomputer and a new computer. That experimental discovery is my contribution to computational mathematics and to the modern calculus. That experimental discovery was the cover story of the June 1990 issue of the SIAM News. The SIAM News is the #1 publication for those applied and computational mathematicians that are interested in learning about new mathematics, such as new partial differential equations that have not yet entered into mathematics textbooks. At the National Computer Conference that took place in New York City from June 7 to 10, 1976, the foremost supercomputer experts warned that parallel processing machines will be too large and too clumsy and a huge waste of everybody's time. In the 1980s, I could count the number of computational mathematicians that were massively parallel processing and count them on my fingers. I know because I was logged on 24/7 on the most massively parallel processing supercomputer in the world. Today, that supercomputer will cost the budget of a small nation. I, Philip Emeagwali, was the most extreme-scaled computational mathematician that programmed the most massively parallel processing supercomputer ever built. I programmed that supercomputer alone. Today, 1,000 supercomputer scientists program only one supercomputer. I was the lone wolf programmer of the precursor to the modern supercomputer because computational mathematicians were heeding the warnings that it will forever remain impossible to harness the power of thousands of processors. In the November 29, 1989 issue of the New York Times, Neil Davenport, the president of Cray Computer Corporation, the sister company to the company that manufactured 7 in 10 supercomputers, warned that, quote, "We can't find any real progress in harnessing the power of thousands of processors," unquote. In an earlier article that was distributed on September 2nd, 1985, and distributed to the print media, and distributed by the United Press International, or UPI. And in that article, John Rollwagen, the president of Cray Research Incorporated, that was the company that manufactured 7 in 10 supercomputers, described his company's use of 64 processors as, quote, more than we bargained for, unquote. I was the lone wolf supercomputer programmer of my new global network of 65,536 tightly coupled processors. I was the lone wolf because the supercomputer scientists of the 1970s believed that it will be impossible to use 64 processors and use those processors to cooperatively solve the toughest problems arising in calculus. The supercomputer scientists of the 1980s believed that it will be impossible to use 64 processors and use those processors to solve the most extreme scaled problems arising in algebra. The supercomputer scientists of the 1980s believed that it will be impossible to use 64 processors and use those processors to execute the computation-intensive floating point operations arising in arithmetic that I executed as the world's fastest computation and executed on the 4th of July 1989. I was the lone wolf internet scientist and supercomputer programmer of my new internet that comprised of my new global network of 65,536 tightly coupled processors that were already available in the market, that shared nothing, and that was 1,024 times beyond the perceived limit of the supercomputer industry. The computational mathematicians that read the supercomputer textbooks cited Amdahl's law to argue that parallel processing an initial boundary value problem of modern calculus and parallel processing those problems across an ensemble of 64 binary thousand processors would forever remain impossible, or at least remain impractical. I'm Philip Emeagwali. I'm keeping this conversation alive at Emeagwali.com. It's been said that out of the heart, the mouth speaks. I've spoken a lot since the 1970s and spoken about how I witnessed the experimental discovery of the massively parallel processing supercomputer. The words I spoke came from my discoveries, heart and brain. I'm giving this lecture because I discovered that the fastest supercomputer must be powered by the largest ensemble of processors. I'm giving this lecture because I contributed to the development of the massively parallel processing supercomputer. I'm giving this lecture because I discovered how to solve the toughest problems arising in extreme scale computational physics. I'm giving this lecture because I discovered the massively parallel processing supercomputer that became the most expensive instrument of extreme scale computational physics. I'm giving this lecture because my experimental discovery of the massively parallel processing supercomputer was the inflection point that opened new possibilities in the world of the computer and in the fields of extreme scale computational mathematics and computational physics that must be used to foresee otherwise unforeseeable global warming, and that must be used to discover and recover otherwise undiscoverable and unrecoverable crude oil and natural gas. My words in these lectures will define me for posterity. To witness a discovery that has rich, fertile, and far-reaching consequences is like walking into a forest and witnessing a lot of leaves fall on your head. Thank you very much. Thank you.
Insightful and brilliant lecture. Insightful and brilliant lecture.